terms are. So exponents is our big theme for today, but we're going to stop for a moment to talk about like terms. So this is like if I have an x plus an x, right? I can add those together because they're the same letter. They are like terms. So I end up with 2x because I have two x's, right? Similarly, or like rewind. I think I may have said that in a way that was confusing and misleading. So let's rewind and restate. So we all know that if I don't have a number in front of a variable, we talked about variables last time, that it's just an imaginary one, right? Because I have one of that thing. 1 times anything is itself. So I can do that. So that's actually what I'm adding here, is I do the 1 plus the 1 to get the 2, and I can do that because they have the same variable. They have a like term. Similarly, I could do 2x plus 3x, and I do 2 plus 3 to get me 5. I can do this because they're like terms, so I'd have 5x. That's a like term. It's you're adding the thing that's the exact same. Let's try it, and I'm sorry about like my light. It's hard, it's blinding out part of it. I'm sorry about that. Let's try it with a slightly different variable, right? Because it doesn't matter which variable it is. If they're like terms, we can add them together. So let's do, I don't know, m. M for Mike. We'll do 5m plus 3m. Take a moment. What is that going to be? 5m plus 3m. M for Mike. Awesome job, you guys. Yes, and I love that people do, I've said this before, I'll say it again. I love that people put a question mark. I love that you're unsure and you're still going for it. That makes me so happy. And you should be proud of yourself for that. It takes a lot to be brave enough to make a mistake. And you'll always learn more from your mistakes than you do from your successes. Awesome. 8m. You guys are killing it. Because I do 5 plus 3 to get 8. I'm adding the like terms to get m. Beautiful. All right, let's spice it up a little bit, make it a little harder, shall we? We're doing it. All right, we're making it just a smidge harder. We'll mix the m's and the x's, okay? Let's do 2x plus 5m plus 3x plus 3m. What the heck is that going to give me? I'm going to take a moment and I'm going to let you guess. I'm going to let you guess. Take a moment, be brave, make a guess. And remember, we haven't talked about this yet. So it's okay if you get it wrong, but you're going to be brave and you're going to guess. Awesome. I love that the guesses are coming in. I'm loving them seeing a bunch of different things. I'm not just seeing one answer because I know why you're getting some of those things. And whenever you get an answer wrong, you're getting it partially right. Okay? All the wrong answers I'm seeing are a little right, and I love it. Beautiful, beautiful. Wow, we're getting a huge variety, and I love that. That's so good. Okay, beautiful, my dears. Beautiful. And you guys are probably like, why are you so happy that you're getting so many different answers? Because that means some of them are wrong, but you're all kind of right. And that shows me what you're thinking. And that helps me be a better math teacher to you. So nice job. Awesome. All right, let's talk about it. All right, so there's a reason why I picked these numbers. I was sneaky. I was sneaky on you. I just combined these last two problems. I did that on purpose. I picked these for a reason. I just combined these last two problems. So when I add a like term, I have to add it with something that's just like it. So they have to have the same exact variable in order for me to, you know, put them together. Got a little Kirishima on you there. Kirishima. So manly. Okay. So we're going to first start with the like terms, okay? I've got a 2x first. I'm just picking x to start with because I'm just reading it. We could start with m. That's fine. I just like to, you know, go down the list. That's me. That's a personal preference. So I look, I'm like, okay, I got an x. Do I have any other x's? I do. I have 3x. Cool. Do I have any others? No, I just have the 2x and the 3x, and I'm adding for all of them. So I'm going to do 2x plus 3x. 2 plus 3. Well, we already know what that is. That is 5x. That's the first part of my problem. I hope you guys can see that 5x okay. So now let's take care of the m's. I've got 5m and 3m. Ha ha ha. 3m. Oh, that's kind of funny. Anyway, 5m plus 3m is 8m, right? Because 5 plus 3 is 8. And now these are all positives. These are all added together, so it's going to be plus. I saw some people who did times, and I get why you did that. You were unsure of what to put there, so you're like, well, I know we got the 5x, I know we got the 8x, the 8m, so I don't know what to put in the middle. Right? We're going to put a plus because everything's added together. We're going to continue to add them. I saw some people do this, where they went 5 plus 8 and got 13. That, however, I like that you wanted to combine it, right? You did 13xm. Yeah, I saw some people do that. I love that you wanted to get it as like simplistic as possible, but we can't do that. We can't do it because x and m are not like terms. They're not the same, so I can't combine them. Okay? You can only combine the terms that are the exact same, the very much exact same. M and X are different, so we have to keep them separate. Does that help? Yeah, the terms are the letters. Good question. So the final answer is 5x plus 8m. Or you could have 8m plus 5x because it doesn't matter the order. Either one is correct, but 5x plus 8m is your final answer there. All right. Let's try another one, okay? I'm going to erase some stuff, and then we're going to keep going. Also, a reminder, if you scrolled in and you don't like what you're seeing, just scroll out. We're having a math lesson here. And if you want to stay, I hope you enjoy. And I know President Mike usually teaches English, but today he teaches math because I'm a math teacher. You don't want me teaching English. I promise you. I promise you. I'm going to be like, what's an adverb? Where does a comma go? I don't know. I just don't know. So we all got things that we're good at. We all got things we struggle with, and that's okay. We try our best at all of them. All right, let's go. Also, I love that there's a President Mike cosplayer on here that like saw these and has started doing like mini English lessons. It makes my heart so happy. All right, we're gonna try another one like that. And then, yeah, the reason why we're doing this is because it's gonna help with when we start combining our doing our exponent rules, because our exponent rules are based on the idea of like terms. And I always say we need to know where something comes from to understand what it is. Because if we don't understand why we can do it, if we don't understand why we're doing it, what's the point of knowing it? Right? What's the point at that point? What's the point at that point? Erase. Erase, come on. Where's my husband when you need him? Oh, I only have bad jokes, sorry. Come on. Come on. Okay, throwing some numbers out there. I know, we'll use E for eraser and M for Mike in this next one. Why? Because I can. Let's go 7E plus 2M plus 10M plus 9E. I am just pulling numbers out of thin air. Give this guy a try. Burp, burp. It's okay. Give it a guess. Remember, it's okay to be wrong. Oh, these are looking very good, my dears. Remember to keep your variables separate, okay? Keep your terms. We're combining only the like ones. All right, looks good. Nice job, you guys. Ah, itch, but I'm in makeup, so I can't scratch. And just tap, tap, tap. All right. Awesome. We'll start with our E, just because it's the first one I saw. You could have started with M. That's okay, too. I just like to do, like, from one side to the other, because that helps my brain the best. All right, I'm going to look for other E's. That's an M. That's an M. Ooh, there's an E. Awesome. That's all my E's. So now I am going to combine them. So we've got 7E plus 9E. 7 plus 9 is 16. 16E. Really hope the Kirishima thing is helping. It's fun for me, at least. All right, 16E. Move that for a moment. All right, so now we've got the M's. 2M plus 10M. 2 plus 10 is 12. I so got that one. I'm good at that. So it's going to be 10M. And the thing that goes in between them is a plus because everything's positive and we're adding everything. Oh, thank you, you guys. 12M. Thank you for catching that. See, it's okay to be wrong. Sometimes I mess up too. Numbers are hard. 12M. I'm like, yeah, 10M plus 2M is 10M. Nailed it. We're going places, you guys. Thank you all for catching that for me. So, someone wrote in all caps, can you mix them? No, we can't. These are our like terms. E and M are not the same. Eraserhead and present Mike are not the same. We keep them separate. So That is as far as I can go. I can't combine things that aren't the same letter. Okay? And remember, I'm seeing things come up for requests on different things to teach. Please send those to my messages so that I can keep them all in one place, okay? Otherwise, they're going to get lost to the abyss, and I'm never going to remember. Because I got that ADHD. Yeah. Thank you for the roses. Also, like, I'm getting a lot of requests, so, like, I just can't go with what I get the most of. So be patient. Be patient. All right. Also, I'm not going to give you information about my students, their age, or anything like that. That's just for privacy reasons. Thanks for understanding. All right. So, let's continue with now exponents. Now that we've got a better handle on variables, okay, in like terms, person who keeps saying cosine rule. Shh. No, send me a request in my messages. We're not talking about that today. And putting it in the chat is just going to confuse me. Thank you. All right, let's go. Oh, no. Erase. Okay. So, we talked about that we can combine like terms. That's a thing that we can do. Burp, 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 burp. I don't know why this is the hand motion we're going with. Oh, if Izao could just erase the board just by like, that'd be so awesome. That'd be so useful. His students would be like, wait, what? Okay. So we talked about we can combine like terms, all that good stuff. Let's talk about what if we're multiplying them, right? Because that's what exponents are. Exponents are when we're combining like terms, right? But we're doing it by multiplying instead of adding. That's kind of cool. So let's first just take a moment to talk about what the heck do they mean? What am I looking at? Because if we can understand what we're starting to look at, we can better understand the rules of how they work. And honestly, if you better understand what you're looking at, my hair's bothering me, sorry. We can better understand how to derive these rules ourselves in case, maybe we forget because we're not using them all the time. So let's get started. Who knows what it means if I have x squared? Who knows what x squared is disguising itself as? This is a really weird way to say it, but I'm going to see if anyone can guess it. Yeah, math with Mike. Awesome. I'm seeing some people get it. Beautiful. It's not going to be 2x. That's very different. It's going to be x times x. So I saw some people say 2x, but remember 2x was x plus x. That's how we got that. When we're multiplying, that's how we get the exponent. Ow, I just closed that on my finger. So this is really saying, if I have this exponent, it's saying this variable times itself that many times. I have two, count them, 2 x's. I have so many more x's than that. But let's not get into that right now, shall we? All right, what if I said I had x to the third? Well, that's really saying that I have x times x times x 3 times. Ooh. This is saying I have 3 x's. X times x times x. X squared was just x times x. Oh, that was a bad thing. 2. I got 2 of them. X to the third, and that's better, is saying I've got 3 x's. If I have x to the fourth, well, you probably guessed it. That means I have 4 x's. Nice job, you guys. Seeing people writing that x times x times x. I got 4 of those suckers. So no matter how many of those you see, no matter what the exponent is, it's just this variable that many times, okay? So if, let's say, you even had x to, I don't know, the 27th, don't panic, that just means we have 27 x's. That's a lot of x's. But all that would mean is we'd have x times x times x, dot, 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 27 times. This is just a lot smaller of a way of writing it, and that's why we do that, because that would take so long to write. I'm not going to write out 27 of them, you know? It's too much. It's too much, Steve Jobs. So that is all that is saying. X squared, we got 2 of them. X to the third, we got 3 of them. X to the fourth, we got 4 of them. X to the 27th, we got 27 of them. X to the whatever number you want to think of, that's how many we got. That's it. So now that we understand that a little better, let's talk about some stuff we can do with that. Some ways we can play around with that. Because mathematics is really about playing around with numbers. All right? We're just playing around with things. And when you can start to think of it that way, it gets a lot easier. So always think of math as something you're just playing with. You're messing around with it. You're manipulating it a bit. Okay? It's just a really elaborate brain teaser that you get to play with. And when you start to think of it that way, it gets a lot less intimidating. It gets okay to get frustrated. It gets okay to be wrong. Just always, for me, try and think of it that way. Okay? So we're going to take this. I'll leave like this first example up. And we're going to talk about some things we can do with it. Erase, erase, erase. Cosplay is warm. I am very warm right now. All right. Let's say I have x squared times x to the third. Let's say I have something like this. And I want to write it simpler, right? So here's how we would combine these. I've got some guesses coming in, and I see where you're coming from, and I love it. I have some right ones, I've got some wrong ones, and I love it. Because even the wrong ones, I see what you're thinking. You got a good idea going there. Awesome, my dears. Awesome. Ooh, someone wrote it out how I'm about to write it out. Nice. Nice. All right. Here's what's up. Let's rewrite it. So x squared really means I've got two x's, right? That's what it means. So let me write that out. I've got x times x. That's what this x squared means. I just rewrote it. X times x. I've got those two from this guy. So now I've got x to the third, right? Well, that's three x's. So I've got x times x times x. So how many do I have altogether? Awesome, you guys. I've got 5. Beautiful. So I would write that as I have x to the 5th power. That's my final answer, x to the 5th power. Now, here is a really quick rule for this, okay? Actually, no, I'm going to make you do another one and then I'll tell you the quick rule, okay? I'll keep it to myself just a bit longer. Take a moment. What is this guy gonna be? Take a moment. What is this guy? Beautiful. And it looks like a lot of you guys have put together what the rule is. I'm pretty sure most of you have put it together on your own what the rule is, because you're coming up with the answer so gosh darn fast. Beautiful, my dears. It is going to be x to the 11th, okay? Beautiful. And how'd you guys get that so fast? Does anyone want to type in how they got it? Awesome, beautiful. You guys are adding it. Amazing. So like, could I take the time to draw out 7 x's and then draw out 4 more and then count them all up? Yes, I could. But if I get into some big numbers, if I get into some big math, that's going to be rough. Right? I'm not gonna have the time for that. So we like to find these quick and easy rules. So I can, if I'm multiplying 2 exponents that are the same, right? I got like terms that I'm multiplying, I can just add them. 2 plus 3 gave me the 5. 7 plus 4 gave me the 11. Amazing. All right, let's try one more, just to really drive that point home, okay? I'm just gonna work it off of this guy so I don't have to erase the whole thing. $92 and $56, what is it gonna be? If you're unsure, look at the rule above it. See if you can extrapolate the idea. Oh, you guys are so wonderful and smart. You guys got this. That's great. And if you don't quite have it yet, remember that that's okay. especially if you're seeing this for the first time. If you want to find my YouTube account, it is in my link tree on my page, in my TikTok bio. Awesome. It's 148, and you guys got that by just adding 92 plus 56. 92 plus 56 is 148. We have 148 x's. That's too many x's. But look what you did. Those are some huge numbers, and you did that so freaking fast, right? That little rule that we took from just looking at 2 plus 3, and that we had 2 x's plus 3 x's to get 5 x's, allowed you to do a bigger problem. You're awesome. Isn't that neat? I think math is so freaking neat. Because sometimes you can find that small thing, and when that works for you, you can make it bigger, and you can solve much bigger problems with it. And honestly, if you're ever asking in your math class, why are we doing this? If you're ever like, this is a weird, simple rule, or things like that, it's honestly because later on, if you continued in mathematics, you're going to build on that rule to do really big things and big purposes. So if you're ever wondering why this is happening, it's because it's the groundwork for something so much bigger and cooler. And it kind of sucks that we teach it that way, right? It kind of sucks that we're doing like this weird little thing and we don't know why, but eventually it does lead to it. And I just think that's so cool. Like, I remember the day, like, who remembers long division? Like, why are we learning long division, right? I remember in one of my upper division math classes, finally learning polynomial long division. And that's something that's just based off of long division, but it's like taking it to that next step. And it hit me. I'm like, this is so useful. This is why we did this in 4th grade. This is why they strived into us long division when I was like, I just have a calculator. Just let me do that. They were prepping us for something so much bigger. And then I went on to college and I got into some really complex math, and we were using long division to do much bigger things. So just know that usually there's the next part, and it's so cool when you get there. All right, let's do something else that's similar, but just as cool, okay? And we started with the multiplying and the adding because it's less scary. So don't get scared with me, but we're going to do division and subtraction now, okay? All right, let's do it. It's going to be very similar, and it's going to build off of this. That's another thing I love about math, is it just builds on top of each other. And like, we're able to stand on the shoulders of people who did math so long ago. And we're able to make bigger and better things because of it. It's so neat. Racy, 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 race. All right. We're going to do division, okay? No one gets scared. Hold my hand. It's going to be okay. Okay? You're not going to get scared of the division, I promise. It's going to be okay. Let's do... We're going to do this guy. We're going to divide them now. Yeah, you got this, everyone. I love the positivity in the chat. That's okay if you're like, what am I looking at? I love that some people are coming in with guesses already. Awesome. If you're unsure, Just write it down. We're going to talk about it, okay? Some of you got this. Some of you got this. All right, let's talk about what we're going to do here, how we are going to handle this, okay? Here's what we're going to do. We're just going to break down for a moment what this says, okay? How many x's do I have on top? On top, I have 5 x's, right? X to the 5th is 5 x's, so I'm going to draw those out. 1, 2, 3, 4, 5. All right, that's what the top says. X to the 5th, 5 x's. That's all that's saying. All right, now we're going to do the bottom part. On the bottom, x to the 3rd, that's really just saying that I have 3 x's, right? Bam, 3 of them. So let's draw those 3 out. Cool. All right, now we're going to use one of my very favorite special rules, okay? And my favorite math rule is that any number over itself is equal to 1, right? X over x is equal to 1. That's the same as saying like 2 over 2 is 1 whole. That's all that's saying. Any number over itself is 1. And if you're confused on that, let me draw you a picture. Let's say I had this piece of pizza or something, and I like cut it in half, and we were like, we're gonna be crazy, we're just gonna do 2 slices. If I have 2 of those slices, I got the whole thing. Same thing for x's. If I have x of the x amount of slices, I've got the whole darn thing. So any number over itself is 1. You can also think of it is that you are canceling it out, right? Some people like to think of it like that you're canceling out those x's. So these guys go together to make a whole. These guys go together to make a whole. These guys cancel each other out, right? How many x's am I left with? Awesome, I have 2 x's left. Bam! You guys nailed it. You're so good. You guys are doing great. So this is equal to x squared, because I have 2 x's left. Nice. Let's try another one like this, okay? I'm going to erase this just so it doesn't get too cluttered. That's a 4. That's a 7 and a 4. Give that guy a try. Also, I know I haven't been saying thank you while this goes, but thanks for everyone who's sending in the roses and little things. You're very sweet. You guys are killing it. Killing it. Nice. These math problems don't stand a chance. You guys are doing great. Awesome. And you guys are coming up with this so fast, right? I think you guys already know what the rule is. I think you already got the rule, because you're awesome. And you're so clever. I'm going to draw it out just in case someone needs to see it, and then we'll talk about what the rule is, okay? Okay. So this is saying I have 7 x's on top. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Awesome. And I've got 4 on the bottom. 1, 2, 3, 4. Beautiful. So now we're going to just start canceling them out and see what I have left. Burp, burp, burp. I'm not going to lie. I find the canceling out part very satisfying. Crossing stuff out, always satisfying. Burp. And I'm left with 3 x's. X to the third. So good. Yes, awesome, exactly. It's basically subtraction. When we were multiplying them, it was addition. When we're dividing them, it's subtraction. You guys did it. You're so good. So all this was saying was 7 minus 4. 7 minus 4 gave us that 3. 5 minus 3 gave us that 2. Amazing. Are you guys ready to try something that might be a little confusing? Let's try something that might be just a little confusing, okay? But just trust me, it's going to follow the same pattern and the same rule, okay? But it's gonna get a little weird. I'm loving the yeses. I'm seeing some no's, but I'm loving that overwhelmingly it's yes. You guys are like, no more, please. And that's okay. If you need a break, if this was too much, if you're like, that's enough math for today, that's okay. If you just want to stick around with the vibes, that's also cool, okay? Let's do it. Let's get weird. Huh? I'm going to keep this example up, and we're just going to rewrite this guy. Oh, I'll write the answer over here. It doesn't look too much harder, but take a moment and think about it. Don't let it trick you. Oh, it's not tricking some of you guys. Some of you it is tricking, and that's okay. Think very hard about it. It's okay if you're like, wait, what? But take a moment. You guys got the tools to do this. Ooh, I just saw one in a different form, but it was still correct. Because I'm seeing a lot in a certain form, but it's not actually your final form. Oh, ooh. Oh, you guys are doing so good. I'm seeing so many good answers and so many good wrong answers, which is exactly what I wanted to talk about. Oh, yes. Yes, we got a fraction form. Yes. Love it. All right. You guys are awesome. These are awesome. Because you all are doing something a little right, and I love that. I love all the answers we're getting. All right, so let's talk. So some of you were like, oh, well, 6 minus 2, that's 4x, right? Right? Some of you were sending me this, x to the 4th. But you're wrong. You're wrong in a very beautiful way. And here's why. Notice that the 6 is on the bottom this time, whereas before the bigger number was on the top. So let's draw the situation out. You were wrong in a very beautiful way, and I love that. Thank you for letting me being able to talk about this. So it's not that one. But I'm so glad that you guys came up with that. Let's draw this out. On top I have 2 x's. On the bottom I have 6. 2, 3, 4, 5, 6. All right, now let's start canceling like we did before. So now I have 4 x's left on the bottom. Yeah? So a way we could write this out, awesome, is 1 over x to the 4th. And that would be its fraction form. That is its final form. Now some of you are saying, you do the subtraction rule, yeah? Where you did, well, I did 2 minus 6. And 2 minus 6 is negative 4. So clearly this must be x to the negative 4. What if I told you that they're the same answer? They're the same thing. But here's the thing. This is really weird. This is why I was saying let's get weird. Is that whenever we have a negative exponent, it's really saying it's in the denominator of a fraction. Okay? X to the negative 4th and 1 over x to the 4th are equivalent statements. They're the same thing. They're equal. But in your math class, okay, and when you're writing out proper mathematics, this would be like leaving it as x to the negative 4th is weirdly grammatically incorrect in math lingo. Yeah, it is. So that's where we bring it to the bottom. If you have a negative in your exponent, you can eliminate that negative by just moving it to the other side of the fraction. That's all. You just move it downstairs and it becomes positive. And that is just a weird math rule. It's just like how we say there has to be a question mark at the end of a sentence, so we know what's happening. That is cool, right? So this is how you would write it as your final answer. This is the final answer form. It's the proper form. This is also the same thing. This just gets rid of the negative by bringing it downstairs. All right, my dears, we're going to try one more problem like this, and then we are going to get going for the day, okay? Because I'm tired. Sound good? Oh, thank you for the glasses. Those are always fun. All right, let's do it. And I'll leave this guy down here. Thank you guys for the roses. You're so sweet. I'll leave this guy down here so that we can work off of it, okay? In case you still need it. Oh, thank you, my dears. Oh, standing up. And if you missed any part of this, it will be uploaded to my YouTube channel later today. You can find it in my bio in my link tree. It should be the first link in my link tree. Yeah. Erase. Okay. Excuse me. I've been liking 7s today for some reason. Take a moment, try this guy. That's a 10. Sorry, it's hard to get the lighting right because this board is shiny. Ooh, I'm liking that I'm seeing it in its final form. That makes me happy. And this is a 10. Let me see if I can write it a little closer so it's out of the glare. That's a 10. Oh, these are looking so good, my dears. Nice job. I'm so proud of all of you. I'm just so proud. You guys are doing so good. Good for you. Good for you. All right, nice job. Let's talk about it. So if I needed to draw this out, I would have 7 on top. One, two, three, four, five, 6, 7, and I'd have 10 on the bottom. Two more. And I'd start canceling them out. This is if you need to draw it out. No shame, right? No shame. Burp, 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 burp. Sound effects make it better. Burp. And I'm left with 3 x's on the bottom. 1 over x to the 3rd. Or if we want to use our fast rule, that glare is just like right where I don't want it to be. There we go. If I want to use my fast rule, I would do 7 minus 10. And I would get x to the -3. And we talked about how to get rid of that negative is to bring it to the bottom. So either way, we come to that x to the 3rd on the bottom.